Hey, what's up? In this video, I'm going to show you how we can make this slider for virtual reality. So here, when we close enough, we get some feedback. That means now we can grab it, get a little bit more feedback. And now, based how much I move my real hand in the direction of the slider, we're sending out this event. So in this case, I defined a range. I said go from 0 to 1 and translate it into percent. But of course, that is highly flexible. You can go to any range you want. And so then I have some other things listening, such as this rocket fire and smoke, and they can all react to it. And of course, when we go all the way, this thing should lift off. Let's take a look at the setup real quick. I'm using the XR origin, that's from Unity's XR toolkit, but that is pretty much the only thing I'm using. I just wanted to have a really quick way to set up these controllers, right? They read the input from my real hand, so to speak, my real controllers, and translate this into this game object. But then this hand grabber, that is a custom script, but that shouldn't really matter too much. I think it should be fairly easy to adjust this to Unity's XR toolkit, because the core functionality is quite agnostic to what is actually happening outside. Just for clarity, let's go through this real quick. So the important thing is I have this handle here that is sitting on the slider, right? The handle, as you can see, everything else is attached to it. So this is the thing we have to move. And it has a handle script. Let's take a quick look. The most important thing is that it implements this interface that I made, Grabbable, which is really simple. It has two snap points. This is just where do I place the physics hand, like the mesh, when I'm grabbing the hand, so it looks like I'm grabbing it correctly, even though my real hand might be jiggling a little bit to the left and right. And just some very simple methods. Start grabbing and this enter, exit range, set closest one. Those are just for the visual cue. The important thing really is this start grabbing method that is asking for a transform. So my hand, like this game object that is moved relative to the hand, it's looking for eye grabbables. Whenever it collides with anything, it says, hey, does that have an eye grabbable interface maybe? And if so, it puts that on a list and says, okay, cool. I'm a hand, so if something's grabbable, I want to know about that. And then when I press the button on a controller, it's going to pick the closest one of all the grabbables in range, and it's going to say start grabbing. And then it's going to pass in its own transform. So that means anything that implements this iGrabbable interface now has a reference to where the hand is actually moving, so how the hand is moving. And so this is where this handle script comes in. It implements this iGrabbable. And here, actually, it's super simple. When I say start grabbing, right? So this is the implementation. It needs just the parameter has to be the same, but then, of course, the functionality, anything that implements the interface can do that completely on its own. So for one, I set the material to the grab material. That's what you saw, like that's this orange glow. And then it sends out this event and says on start grabbing, and it passes on the reference to the hand anchor. So this is just a public event action sending out the transform. So that means anything that has a reference to this handle can subscribe to this event and listen to it. And that is what the slider does. So we'll quick the handle script right in here, that's setting on here. And it has a capsule collider, so the hand can actually collide with it. And then this is the slider script. It has reference to the handle. Let's take a quick look at that. So here the slider, first things first, a reference to the handle that I can simply assign in the inspector. Also has reference to this thing. I explained that in my last video, just a way for me to have like dynamic game mechanics. Doesn't really matter. You could also only rely on this event that we're going to send out. We're going to get to that in a moment, but this is ultimately the result of what's going to happen, right? When we move this thing, it sends out this event. So other things can see, such as the display, oh, this has changed. But okay, let's first things first. So we have a reference to this handle, and in on enable, I'm going to say, okay, when this handle sends out the on start grabbing and on stop grabbing, we want to react to that by calling this method called start grabbing. So the transform, one more time, it gets passed on. This is still the hand. Like the moment the hand grabs, this goes through like the chain, and then the slider actually knows, okay, this is the grabber. So we save a reference to it because we're going to need it, because now obviously we want to react to when this hand is moving. I also have this boolean here is grabbed equals true. Technically, you could also say active grabber. If active grabber is not equal to null, then we know something is grabbing, but sometimes a little boolean can make things more easily. Okay, now let's get to the gist of it, and I think it's actually easier to explain that to you first in the scene view. What we want to figure out is as soon as we start grabbing, we have this handle here, right? It has this z-axis, and we want to figure out how much has the hand moved on this axis since we started grabbing. So let me get, for reference sake, I'm going to grab this hand here. It says green because I changed the color. That's from the VRIF, the VR interaction framework. So what you see here, the transform, that is always the local position, which can be a bit confusing in the beginning because when you use transform.position in the script, it's going to give you the world position. And that would be, if you can keep looking here, right, if I move this out and it has no more parent, now the local position and the world position is the same. But of course, as soon as I move this as a child of just about anything, this is going to change because now it shows me the local position. And the local position is simply relative to whatever it is parented to. And that means, second, where was it? Okay, so we have the handle here while we want to move here. And basically, the handle, that Z is referring to its parented to the base, right? As you can see, this is also the same rotation. So we kind of just want to know, like, okay, if the hand were a child of the base, so if it were a sibling of this handle, because then all we'd have to read out is the Z position. So kind of like this, green gloves. Let's move them in here into the base. So now the handle and the green gloves are siblings. If I move this, whoops, a little bit like this, right? And now if, once again, this is the local position. Now if I move the Z here and I try to only move a little bit, as you can see now, it is moving exactly like the handle because now they are aligned. And so that means even if the hand kind of moves like whoops, like this, or basically anything, the Z position is still referring to this axis of this handle. So now basically what we have to do is, right, we have this left hand or this right hand controller that has this hand grabber. So as soon as we start grabbing, we want to see where would that be in this local position and where does it move. And we don't want to parent things around. We obviously want this still to be parented to the extra origin and everything. But what we can do is use this awesome method called inverse transform point, which honestly sounds more complicated than it is. All we do is we pass in a transform. That is now the transform that we want to know. If this were a child of it, whatever position we pass in, if this were a child of this thing, right, this position, this is the world position, what would that be in local position? Hope that wasn't too confusing. So this is the transform on which we call this inverse transform point. And I just grabbed the parent of the handle, which is going to give me a slider, the base, right? So if I say this transform.parent, that gives me the base. And then I say, okay, let's put this grabber, that's the one that's grabbing it, the left or the right hand. And let's see, what if this were also a child of this base? We pass that in. And now we have this vector 3 that gives us the hand in local space. Now all we have to do is, for one, we save the local position of the handle because we only want to move by how much it has moved. We don't want to like move the handle right away to the hand or something. That would just lead to weird snapping and stuff. So it's all about like how much did we move since we started grabbing. And we're saving this offset on grab, and all we care about, right, is that Z position, right, the blue vector, that's the forward. So we translate handle in local space, and then we offset on grab, and we save that when we start grabbing, because now that this is true, it means that, whoops, in this update, we are grabbed, so we move to the hand. And now what we do in these two lines is we just figure out how much have we moved since this grab action started. And that is super simple. Once again, we pass in the position, the active grabber, right? We saved that when we started grabbing. Where is it now? And of course, we translate this as if this were a sibling of the handle. And then we just get the difference. And we say new hand position minus offset on grab. Now that we know how much the hand has moved relative to the handle local Z axis, we can just use that and figure out how much the handle should actually move. So we're going to calculate the new Z, and we're going to use the start position. This is the one we saved the moment we started grabbing, right? We just get handle.transform.local position. And we're also going to use that to not move on the X or the Y axis, so we only move on the Z. And we're also going to use this vector 2 handle start and end local Z. So I'm just using here a vector 2. It's just to bundle two float values, right? I want the minimum and the maximum. I want them to be tied together. So use a vector 2. So this one dot X, that's the lowest local Z position we can go. And of course, the Y is the highest we can go. So we save the start value. And in here, we want to calculate the new Z, and we're just going to clamp it. So right, this is where we started. We add how much we have moved, which of course can be positive and negative. And then we clamp it between this handle start and end local Z dot X and Y. So the handle is not going to overshoot this actual mesh of this slider. And here I'm also using this old Z, and that is just because I have some slider with restrictions. Maybe you need it, maybe you don't. It can be quite useful. Right, so if it's set to lock, then I'm not going to move anything because the slider is locked after all. And this old Z, I just use it because sometimes I want to restrict it that it can only move up or it can only move down. And I just say, okay, we can only move up, but the new Z is actually lower than the old Z. We're going to return and nothing's going to happen because so far we haven't really moved the handle. We only calculated how much we want to move it. Now, if we get past all of these checks, right, the lock and the up and down, that means it's now finally time to move this handle, the actual game object. And for that, we just going to handle.transform.local position, make a new vector 3. We use the start position.x, start position.y. You could also save this when the script starts in a wake or something, right? Because the point here with the x and y is just don't ever change it, because then the handle moves left and right or up and down, which of course you might want. And I think this is also why the script is quite flexible, because you can restrict it to all kinds of directions. But for this one, we're only using the Z, right, the blue vector. And now, of course, we have the new Z, we calculated it, passed it in, and now this handle has moved. So far, we've only moved the mesh. Now we also want to make sure that other scripts can know about this and they don't have to do any kind of math. All they really care about is what the slider sends out in this event. This is called a public event here on new slider value. And we are using this output range. This is just how I define what is the value that's gonna get sent out based on where the slider is. So the example I just showed you, I simply put it to 0 and 1. If the slider's all the way down, it's 0. If the slider's all the way up, it's 1. But for example, I also have this rotation slider that I use to rotate the rocket, like on the, say, like the x-axis left and right and the y-axis left and right. No, the z-axis. Point is, sometimes I want to use -1 and 1. So when the slider is in the middle, it's going to be 0. And when it's down, it's going to be -1. And so by simply using this output range, I can just put in any value I want. If for some reason I want this to be 3 and 5, then it would also work with that script. And the first thing we have to do is figure out what percentage is the handle right now between the positions it can be. And for that, we use inverse lerp. Might actually be easier if I explain lerp to you, because you probably have already used it. Right, lerp is basically tells you I have a value 1 and I have a value 2. And then I want to pass in something 0 to 1, a value between 0 to 1, and say, give me the percentage of those two values, which is incredibly useful, especially for positions, right? Sometimes you have position 1, position 2, and then you pass 0.5. So it says, I want to be right in the middle of these two vectors. But of course, you can also use it for floats. And inverse lerp is basically the opposite. Is we have value 1, right, our lowest possible z position, value 2, our highest possible z position. And we say, okay, I already know where I am between those two, the new position. So what's that in a percentage? And so this is going to return anything between 0 and 1 if I pass in a value that happens to be between those two. Right? If I were to pass in this value here in the end as well, then I would get 0. And of course, if I were to pass in this y value here in the end, then I would get 1. And then I get anything in between those two. Now I have the percent, what this is, and then we just translate this into this output range. So it's not just 0 and 1, but 3 to 5 or whatever you want to choose. And then we have that. And then we just send out this on slider value, public event, anything can listen to it. We send out this new value, and now they can react to this. For example, this display. This is the thing that I mentioned in the last video where I have this mechanics, and here I just hook up a mechanic directly and say like, I want to change this thrust mechanic. Don't have to do this, but usually this can be all you want. Just send out an event. Technically, you could also tell the slider then to something directly, but then you're coupling your objects. And with this event, you keep things nicely decoupled. So that's pretty much it for the functionality. I think I can show you the display real quick. Very simple, has reference to a slider. Of course, the value, string a prequel. Sometimes I want to say like thrust equals, and then I want the actual value. Also here, I use this quite a lot, so show percent. And in on enable, slider is null. Not sure I use get component when I have a serialized field. No slider was assigned to here either, just me trying to write code that's robust, but yeah, sometimes a bit verbose, but yeah. Point is, we are going to subscribe to the slider. I'm using here, even if it's not okay. That's ignore that, but let's just pretend you didn't see that. Of course, we always assign the slider in the inspector, and then we can say slider. When the value changes, I want to update the display. Here, if I show percent, right, I use this percent thing and multiply with 100. Maybe I just want to show this directly and like show 0.1, 0.2, right, the F1. And of course, in onDisable, we unsubscribe. One last thing that might be of interest is when I have this handle, I have these two transforms. Those are snap points. And I simply use them to position the hand correctly, right? So the slider doesn't know anything about that and shouldn't have to know anything about that. And let's see where I use that. So here, oh yeah, they are just public getters, so other things can use that. And I use that on the hand. Hopefully this is kind of live. I haven't prepared that. Hand grabber. Okay, so this is the hand grabber script, the one that's sitting on the game object that is actually moving the hand, right? And it just says when we try to grab something, which is hooked up to the actual button on the controller, where we check, do we have grabbables in range, right? We get the closest one, which is hopefully the handle of the slider for this one. And then we just save reference to this grabbed snap point. And we can use this when we position the physics hand. So when we grab something, we know, okay, I have this transform that has a position and rotation, so I can use that and pass that on and then position the hand model correctly. Right? And I use left and right because they are a bit different. We can go in here, slider handle, snap point right is this, snap point left is this. And that totally depends on your hand model, where they are parented. So you just have to try it out a little bit, position and rotate them correctly. But now that means the moment I grab it, right, this snap point is parented to the handle, and then it says, okay, this is, make this the parent of the hand. So now the hand is, well, sorry, not make it the parent, but just read the position and rotation. So I have this, the actual hand model here parented, and it looks like it's always grabbing. Because obviously the real hand, and that means the one that we're moving here based on the real hand, It could be moving left and right and up and down a little bit, and you don't want that, right? You usually want the model to kind of stick to this. You could actually enable like rotation around this handle axis. I think that would look pretty cool, and I think I'll do that soon. But the main idea is, of course, the hand stays here. And maybe, depending on your game, you could say, okay, if the real hand is like way too far off, you kind of like, you forcefully ungrab this thing. But yeah, completely up to you. I hope you learned something. I hope you can use this. I think it's a decent system that allows for a lot of things. Like you could pull things out, and the moment they are completely pulled out, right, you reach the minimum or the maximum, then you have like free movement, put them back in, kind of like this thing. I want to make a game soon where you freeze particles or something. So you have like this cool freeze sliders that you pull out and then place on the table and whatnot. Lots of ideas. Yeah, if you have any questions, feedback, just let me know. Of course, always ideas for things you'd like to see. I'll do quite a bit of virtual reality in the near future, and then like the larger system design stuff. So hope you enjoyed it, hope you learned something, and of course liking this video, subscribing to my channel really helps me out, and of course making it all the way to the end, that's also really useful. Thank you and goodbye.